Okay, everybody, one more problem. We want to use unit vectors to find a vector difference. And we're going to use the same first two vectors from the last example. We'll call this example 2. And we're going to find, we want to basically find the vector difference b minus a. Now, recall that vector b, as given in the previous example, in unit vector notation, it was the following. It was minus 2 meters I hat plus 3 meters j hat. Vector a was as follows. It was 4 meters I hat minus 2 meters j hat. Now what we want to do is we want to find vector b minus vector a, and if you recall, if we were doing this head to tail, we would take vector b and we would add the negative of vector a graphically, head to tail. Now, how is this going to work with unit vectors? Well, it's going to work like this. Simply what we're going to do, if you recall when we did it before, to find the vector difference, to find dx, just as reference, we took, it would be bx minus ax to find the x component of the vector difference, and the y component dy was simply by minus ay. So we're going to follow suit here with that. And what it's going to look like, it's going to be this. It would be bx minus ax I hat plus by minus ay j hat. So we're just doing components. Subtracting the x components, b minus a, subtracting the y components, by minus ay, and keeping the unit vectors in the loop, so to speak. So working out the numbers, we'll simply have, we'll take bx, and we look carefully here, this would be minus 2 meters, minus ax, we're just going to subtract this 4, this would be minus 4 meters, and that's going to be I hat. For the y part, dy of the difference, we're going to take by, which is 3 meters, and we're going to subtract ay. Now ay is a minus 2, so it's going to be minus 2 meters, like so, and this would be j hat. Then combining numbers by simply doing the arithmetic operation, we'll get minus 6 meters I hat plus 5 meters j hat. So it's a pretty straightforward basic problem. So this is d, the vector difference, which in turn earlier was vector b minus vector a. So it's a pretty straightforward problem. Now, if we want to express this answer, this is done in unit vector notation, but we want you to be comfortable with converting it back to what's called magnitude and angle notation. So in part B, we would want you to be able to express the answer in magnitude and angle notation. So we're going to have to draw, as we did before, dx plus dy, head to tail. We're going to have to go there. Well, here's dx minus 6. Here's dy plus 5. So let's make it happen. So if we go minus 6, I'm going to come down here and actually draw this thing and use the graph paper to do it. So we're going to put point P right here, which would be our origin. We're going to go over to the left 6 arrows, 6 blocks rather. Okay, there's minus 6 meters. That's dx. We're going to do head to tail here. dy is going to go up 5. We're going to draw that in. Okay, that's 5 meters up. That's dy. And then we've got our vector difference. Again, I'm going to turn the paper so it's easier for me to draw it for just a second. This is going to be our vector difference. Okay, there it is. And we'll have to find its magnitude. And we'll have to find the angle down near the origin, theta d. And it's, as usual, the Pythagorean theorem for the magnitude. We find the hypotenuse of a right triangle. We take the legs, the square root of the sum of the squares of the legs. This is going to be minus 6 meters squared plus 5 meters squared, the square root of the sum of the squares. And we're going to take the square root of 61 meters squared when we combine the numbers. And simplifying that to one decimal place, we get that the magnitude of the vector difference is 7.8 meters. To get theta d, we would use the inverse or arctangent of opposite over adjacent, which would be dy over dx, which would be 5 meters over minus 6 meters. When we work that out on a graphing or trigonometric calculator, we get minus 39.8 degrees. Now, if I wanted to get the angle counterclockwise from the positive x-axis, we would want to take a look at how to do that. And if I go back to the drawing, everybody, here's the positive x-axis right here. I've just highlighted it or drawn it. And so suppose we want to specify this angle right here. Well, very simply, that angle would be 180 degrees minus 39.8 degrees, which would get us an angle of 140.2 degrees counterclockwise from the positive x-axis. So the entire answer here for the vector difference in magnitude and angle notation would be 7.8 meters at 140.2 degrees counterclockwise from the positive x-axis. So once again, we need to be able to do magnitude and angle, which seems like at this point a little bit more work than the unit vector notation method done up above. So we've got to be able to go back and forth between each one of these and feel comfortable about it. Now, the assignment that you are going to have, it will be posted online for you to do.